Primer. Getting started with the Arduino. Hardware. First, let's look at the Arduino Uno board and a few pieces of hardware that you'll use in almost every project. The Arduino controls components you attach to it, like motors or LEDs, by sending information to them as output. Data that the Arduino reads from a sensor is input. There are 14 digital input/output pins, pins 0 to 13, on the Arduino. Power. When you connect the Arduino Uno board to your PC to upload a program, it is powered from your computer's USB port. When the Arduino is not linked to your PC, you can have it run independently by connecting it to a 9V AC adapter or 9V battery pack with a 2.1mm jack, with the center pin connected to positive power. Hardware. Breadboards. A breadboard acts as a construction base for electronics prototyping. Today's breadboards are made of plastic with pre-drilled holes into which you insert components or wires, which are held in place by clips underneath. Breadboards come in various sizes: 3 breadboards, 1 full size, typically with 830 holes, 1 half size, with about 420 holes, and 1 mini board with 170 holes. Jumper wires. You'll use jumper wires to make connections on the breadboard. Jumper wires are solid core wire with a molded plastic holder on each end that makes it easier to insert and remove the wires. When you insert a jumper wire into a breadboard hole, it's held in place from beneath the board by a small spring clip, making an electrical connection in that row. Programming the Arduino. The IDE interface. The IDE screen is divided into a toolbar at the top with buttons for the most commonly used functions, the sketch window in the center, where you'll write or view your programs, and the serial output window at the bottom. The serial output window displays communication messages between your PC and the Arduino, and also lists any errors if your sketch doesn't compile properly. Libraries. A library is a piece of code that carries out a specific function. Rather than enter this same code repeatedly in your sketches wherever you need, you can simply add a command that borrows that code from the library. This shortcut saves time and makes it easy for you to connect to items such as a sensor, display, or module. Installing libraries. 1. Choose Sketch. Include library. Add.zip library. 2. Browse to the zip file you downloaded and select it. In older versions of Arduino, unzip the library file and put the whole folder and its contents into the sketchbook/libraries folder on My Documents /Arduino/libraries on Windows. Testing your Arduino. Blinking an LED. The build. The blink program turns an LED on for 1 second and then off, repeatedly. The LED works only with current flowing in one direction, so its longer wire must connect to a positive power connection. LEDs require a current limiting resistor or else the bulb may burn out. There is a built-in resistor in pin 13 of the Arduino that we'll use. Insert the longer, positive leg of the LED to pin number 13 on the Arduino, as shown in figure. Connect the shorter, negative wire to the GND pin next to pin 13. Connect the Arduino to your computer with the USB cable. Open the Arduino IDE on your computer, then choose File Examples Blinking LED from the drop-down menu. The sketch will appear in the main program area of the IDE. In the IDE, click the Verify button to check that the sketch is working correctly. Click the Upload button to send the sketch to your Arduino. Running this code should make your LED flash on and off. Testing your Arduino. Blinking an LED. Line 2, this gives pin 13 the name LED. Every mention of LED in the sketch will refer to pin 13. Line 3, the code between the curly brackets, will run once when the program starts. The open curly bracket begins the setup code. Line 4, this tells the Arduino that pin 13 is an output pin, indicating that we want to send power to the LED from the Arduino. The closing curly bracket ends the setup code. Line 5, this creates a loop. Everything between the curly brackets, after the loop, statement will run once the Arduino is powered on and then repeat until it is powered off. Line 6, this tells the Arduino to set LED, pin 13, to high, which sends power to that pin. Think of it as switching the pin on. In this sketch, this turns on the LED. Line 7, this tells the Arduino to wait for 1 second. Time on the Arduino is measured in milliseconds, so 1 second equals 1000 milliseconds. Line 8, this tells the Arduino to set LED, pin 13, to low, which removes power and switches off the pin. This turns off the LED.